So welcome everyone to CryptoBind Digital Insights episode 3. Uh, Today we'll be unpacking a buzzword called PET, Privacy Enhancing Technologies. It comprises of tokenization, data masking, and encryption. So these three words are thrown around in cryptography and in data protection field quite often. In today's webinar, we're going to unpack what these terminology actually mean, their use cases, and how ahead we as an ecosystem, we as a GSOS of tech are doing things differently for tokenization, masking, and encryption. To discuss this, we have Gaurav and Harsh with us. So I'll come directly to Gaurav. Gaurav, privacy enhancing technologies have become privacy enhancing technologies have become a buzzword over the last few years. Okay. So what exactly are PETs and how does it differ from security? If you can elaborate on this point.
Yeah, so once again, Shada, thank you so much for inviting us for this webinar. So as you spoke about privacy enhancing technologies, let me give you a simple example to understand the concept. So, you imagine that, your house, it has a gate, it has locks, and, it has many CCTV cameras. So these are all the security measures, their job is to stop unwanted people from entering your house or inside your house. While now, inside your house also you might have, a lot of precious, items like your jewelry, important documents, which you keep it in your locker. So if someone somehow, enters your house, they can't find these items if they are inside a locker. So that is exactly how privacy enhancing technologies or PETs work. Traditionally what used to happen, the traditional security used to focus on protecting the systems or the networks through firewalls, access controls, network defenses. But PET, it goes one step further. So they protect the data itself. So even if someone gains access, the sensitive information which remains basically like, your cards, your credit card details and all those things, it remains masked, tokenized or encrypted in this manner. So, making it useless for an attacker. So in simple word, I can say that, security protects the environment while the PT, it protects the data itself and data wherever it goes, maybe, within the system or outside, anywhere.
Yeah, that's good. So what we have seen traditionally that organizations relied heavily on the perimeter security. So according to you, why has this shift towards protecting the data itself? The recent shift has been shifted towards protecting just the data itself.
Yeah, fine. I understood what you said, your question. So Shada, basically, the shift has been majorly because the way we work and the way we work nowadays has completely changed. So earlier what used to happen, most of the applications and the data, it used to actually reside within the organization's own data center. So even if during that time, if the network is safe, the data used to be fairly safe. But today, the scenario is totally different. What is happening is that data is everywhere. So the data is stored in cloud. Even we share the data with our partners. It is accessed from mobile devices nowadays. And nowadays, due to the work from home culture, the employees are even working from their home location or different locations. So, there is no single boundary to protect anymore, which was the case which was different in the earlier scenario. So what happens at the same time, the cyber attacks it has also become very sophisticated. So even if you have a strong security, there are ways, there is always a chance that someone can get into that. And that is why organizations are changing their approach nowadays. So instead of protecting the network, they are now making sure that the data itself remain protected. So, if the customer data is encrypted either or tokenized or masked, so even if there is an attack or the attacker gets hold of it, they can't actually use it or understand it. So nowadays, the question actually is not that can someone access my data. The real question nowadays has changed, and it has become like, if even if they have my data, will the data be still protected? So that has changed, and that is why the shift into the this scenario.
Yeah, that's a great way to put it, Gaurav. Just protect your jewelry, not just the gate. Yeah. So, Gaurav, encryption being the probably the oldest part of the PET, privacy enhancing technologies, uh, and it has been around for decades. So, why is it still considered the foundation of data protection? Encryption just being the foundation of data protection.
Yeah, because encryption solves one of the biggest challenges in the cybersecurity. It makes the stolen data useless. And you think of it like sending important letter in a language which it is unreadable. So only the person you are sending it, that person can decrypt it and and then see the original data. So this is the reason the encryption has it has stood the test of time. So that is, it is effective across almost every situation. So whether the data is stored in database, whether it's traveling on internet, it is backed up in a cloud. So encryption keeps the data protected. So encryption is the only as strong as the way you manage the keys. So encryption keys, if they are safe, your encryption, your the data is safe. So if the keys are not protected, the encryption loses its value. And nowadays, that is the reason why all these organizations, they are combining the encryption with secure key management using solutions like hardware security module, which is HSM, and key management systems, which is also called KMS. So, our takeaway from this is basically that encryption is still the foundation of data protection, because even if the data is stolen, it remains unreadable without the right kind of a key. That's it.
That's good. So just a follow-up question on that regarding the encryption. I wanted to talk about more on the stages, right? So there could be three different stages in encryption. It's data at rest, data at in transit, and data in motion. Can you also explain these different stages for us?
Yeah, of course. So a simple way to understand, once again, the data of journey. So data is basically usually in one of the three stages. So as you said, that data at rest. So this is data which is stored in your database or hard disk or a cloud. So what we do, we encrypt it so that even if someone gains unauthorized access, they still can't read the information. Second, as you said, the data in transit. So this data is moving from one place to another. For example, when you're making an online payment or you're logging into your bank account. So encryption protects this data while it is traveling over the internet. So no one can intercept and read it. So when an application is or a user, when an application or a user is actively processing the data, this is the most challenging state, because the data is because the data usually needs to be decrypted for the application to work, and that is why the newer privacy enhancing technologies are becoming very important. They help protect data even while it's being processed. So in simple terms, we can say, Shada, that data is either stored, moving, or being used. To protect it properly, organization need to secure all these three stages and not any single stage. I hope that answers your question, Shada.
Yeah, it does. It does, Gaurav. So, thank you so much for answering the encryption and the stages and what encryption is all about. I would like to bring in Harsh and for this next question. Harsh, organization often hear terms like TD, file encryption, application level encryption, and field level encryption. Can you just throw some line on how are these approaches differ from each other?
Yeah. First of all, I would like to check if I'm audible and,
Harsh.
is there any lag, because I have some issue with the network over here. So am I audible?
Yes, you are audible. Oh, Harsh. Please go.
Yeah,
Okay.
yeah, Harsh, we can hear you.
Right. Okay. So, well, in the previous question, I think Gaurav has already explained with regards to data at rest or data in transit, but the kind of encryption that needs to be applied to your data, it also relies very heavily on the type of data that is there and at what level or at what, say, granularity are you trying to enforce the encryption. So these are also two very important, say, factors or parameters which determine the kind of encryption. Now, when there are so many terms in the market, such as you mentioned, file encryption or application level encryption. So this is what is basically covered in these two types that I said, whether we are trying to protect structured data or unstructured data. So in that case, for structured encryption, data encryption, we have got database level encryption, or further inside database level encryption, as I said, depending on the granularity, we have table space encryption or column level encryption. If you say want to focus on the unstructured data, then that is where you target the file systems or the storage servers and file repositories. Basically, that is where the encryption is applied. Application level encryption is again where you're making the changes into the application to say perform the encryption before it is getting transmitted, before the data is transmitted via any communication channel to another database or another application. So that is how the overall picture sits, So if you say that you want to perform data in transit encryption, then, and data in transit, and let me be even more specific in this case, if you don't want to say rely on SSL TLS, that is basically a channel encryption, or it is a protocol that encrypts the communication channel. If you want to actually focus on encrypting the data packets, then that is where you have to say enable the encryption at the application level itself to achieve data in transit encryption. To achieve data at rest encryption, if you want say structured data protection, then you have to do database encryption. If it is file server encryption, that is for unstructured data. So this is how the entire say picture sits in some kind of a hierarchy, wherein some of it makes sense or correlates, but some of it is targeted or very specific to the use case. If you see data in use, then there is again some specific techniques which allow you to perform operations on encrypted data itself, that is called as homomorphic encryption, or else you can even consider certain tokenization techniques or masking techniques wherever the data is already in use, but it is in some partially or fully protected manner. So this is how the whole picture sits.
All right. Implementation complexity. I mean, how can enterprises reduce this implementation complexity while they deploy this, the deployment efforts and still protecting the most sensitive data? So if you can, elaborate on this as well.
So, well, part of it relies on the initial part of say discovering or having the right picture in of all the assets that you need to protect, So if at all there is a lack of visibility, then obviously that goes into a scope where you need to perform certain data discovery activities beforehand to understand your entire landscape, to understand where the sensitive data resides, what needs to be prioritized over the other. That is the first step. Then after that, again, it comes as to how much do you fall under the specific compliances or what the compliances dictate as to what kind of protection or how sensitive data needs to be protected to meet certain compliances. So for most of these, say, compliances, you can use certain plug and play techniques. So if we talk about database encryption specifically, there are various options. The most straightforward one is tablespace encryption, which targets your database files. But imagine this, that you have an envelope, and inside this envelope, you have the files in which there is some confidential information. So if you're going to implement the tablespace level encryption, you're going to focus on putting a seal on the envelope. It's not actually making any changes to the data on these files. Okay, so when the database system gets initialized, it is basically going to get decrypted once it fetches the key, whether it is from the HSM KMS. If HSM KMS is not there, which is not an ideal scenario, then from the database instance itself, it is going to fetch the key. and it is going to say allow the users to access plain text data. Now, the challenge here is that anytime you perform any kind of operation on the database, whether it is a read-write operation or any kind of SQL query is fired, the data is present in plain text format because that has not been altered with. It is just the encryption decryption that has taken place when the system was, say, turned off or when it is initialized. So you're protecting a scenario wherein if anybody tries to take a backup of your data, that is going to remain encrypted as long as you don't have the key where you're trying to restore that data. Or another scenario is if somebody is going to physically say, if there's a scenario or any case when you want to protect from physical theft of the storage disk, then this kind of an encryption solution will protect the data in the case of theft. But when you want to protect it based on the role-based access control, so the users trying to access this data or the specific applications that are connected to the databases that should be allowed to fetch plain text data, this is where you need to focus on protecting the data on a much more granular or finer level called as column level encryption. Now, organizations mostly don't prefer this approach. Column level encryption is something which if you haven't done, if you don't have the native licenses, first of all, which are very expensive. So with native licenses, you can do the first approach, that is table space encryption as well as column level encryption. But if you don't have native licenses, if you want to do column level encryption without native licenses, then that creates a lot of challenges, because the encryption essentially what it does is that once you perform the encryption on any data, it is going to scramble the data, it is going to create a ciphertext, and depending on the algorithm, in most cases, you're not going to get the data in the same format as it was in plain text. So this encrypted value needs to be, say, consumed or be, say, stored in the databases, right? So if your database schemas or your database column types or the entire schema is not aligned with handling this encrypted value, then that is where your column level encryption essentially fails. The cost of making these changes may not be something which the enterprises or organizations want to consider in the pursuit of enforcing a much more stronger level of protection. So it is really all about, I would say, striking the right balance amongst all the other things. As I said, discovery of the data, understanding your ecosystem, understanding whether it is the right thing to do to purchase enterprise licenses or use third-party solutions, and also about how complicated it is going to be to achieve the required amount of security. Now at CryptoBind here, we have one solution which targets this specific challenge, wherein you don't need to rely on any enterprise level licenses. You don't need to rely on making changes to the database schemas. You don't have to make any major changes in the application code to say enable the application level encryption either. What you can simply do is you can use this solution, which we call Zero Code Encryptor, as a plug and play solution to encrypt the data. And thanks to the development of the solution and the overall engineering that has gone into making this solution, we have ensured that we utilize certain format preserving encryption techniques. We identify the data on the fly that needs to be encrypted, so you can specifically target the sensitive columns, and your data at rest and in certain scenarios, even in transit, can be protected completely. So there needs to always be the right awareness in the market about such solutions. Enterprises need to, say, evaluate these amongst all the other techniques as well. And that is where they can really find the perfect solution, which protects the data and also reduces the implementation complexity.
That's great, Harsh. And if I'm not wrong, Jesus Softec is getting a lot of inquiries on ZC innovation technologies that you have just mentioned, right?
Yes, I mean, because as I said, it solves a very fundamental challenge wherein in acquiring licenses, these organizations have to bear a huge cost. Enforcing the highest level of security, then in that case means, again, making certain changes. So in any scenario wherein there are any legacy applications or any systems which cannot be altered to a great extent to enforce column level encryption. This is exactly where our solution sits perfectly and helps organizations align with their compliance requirements.
Yeah, that's great. Thanks for giving those insights about ZCE and other things. I would like to shift this focus to more progressive into quantum computing, and would like to come to Gaurav. Gaurav, how do emerging technologies like quantum computing influence encryption strategies? And should organizations already be thinking about crypto agility?
Yeah, so Shraddha, actually, this is the right time. Organization should start thinking about quantum computing or migrating onto this new technology, because quantum computing is still evolving, but it has still the potential to break some of the encryptions which we encryption method which we rely on today. That doesn't mean that today's encryption is unsafe. I'm not saying that, but it becomes so it does mean that we need to prepare for what's coming. So we also need to understand that there's one more concept which is very prevalent, which is called harvest now and decrypt later. I just give you a analogy, like you have to imagine that if an attacker steals the encrypted data today, so they may not be able to read it right now, or because they do not have that capability to break that algorithm. But so what they do now is that they simply store this, and years later, when the powerful quantum computers will become available, they could decrypt the same data. So this is actually especially concerning for the information that remains valuable for a long time, just like customer identities, or the healthcare records, financial informations, or intellectual properties, or you can say the government data. So that is the reason why organizations they can't afford to wait until quantum computers become a mainstream. So this is where the concept of crypto agility comes in. So think of it like updating your phone's operating system. So you don't wait for it to stop to update it. Because once you update it, the data on the phone remains protected with the new threats. So similarly, the quantum or the crypto agility is design. Agility means it designing your system so that you can replace or upgrade the encryption algorithms without rebuilding your entire application. So when the quantum safe encryption becomes a new standard, so organizations who have already moved, or organizations with crypto agility systems, so they'll be able to make that transition much more smoother. So that is the reason why crypto. This is what basically is the crypto agility, and it's very important.
No. All right, Gaurav. I would like to shift this focus from the other privacy enhancing technologies apart from encryption, that is tokenization. And
Sorry,
I'll come to Gaurav itself, and if you can help me with decoding what basically tokenization is all about. I mean, at a high level, what is tokenization and how is it fundamentally different? Yes, you are, Gaurav. If you want me to repeat the question?
Yes, Shraddha, because actually
Okay.
I could not hear your
So-
question.
So we are talking about the other privacy enhancing technologies, other part of the privacy enhancing technologies called tokenization. And tokenization, as it's often confused with encryption. So at a high level, what is tokenization and how is fundamentally different? If you can help us with a normal layman's example.
Okay. So let us understand tokenization with the help of a very simple example. So imagine you go to Starbucks and you order a coffee at Starbucks, and after placing your order, you will receive a pickup token or order number. So now if someone sees that token, they can't tell what you ordered, how much you paid for it, or like other details like personal details of yours. The token is simply a reference. So only Starbucks system knows which order is linked to that particular token. And exactly that is what is tokenization, and that is how tokenization also works. So instead of storing sensitive information like credit card number or the Aadhaar number, the system replaces it with a random token. The token has no meaning on its own. So it doesn't reveal anything about the original data. The real information is stored securely in a separate system, and only the authorized application which have the privilege can retrieve it, and only when it is needed. Okay, so encryption actually works differently. So as we were talking about encryption earlier, the tokenization is replacing the data, and encryption, it doesn't replace any data. It converts the original information into an unreadable format. So if you have a correct encryption key, only then you will be able to convert back the original data and able to read that. So the easiest way to remember this, the differences: encryption hides the data using a key, while tokenization replaces the data with a meaningless token. I hope that answers your question, Shada, and I think
Yes.
there's a lot of
Yes.
technical glitches, so I'm sorry for that.
Yes, it does, Gaurav, and that's a nice way to explain, by the way. So, Gaurav, just a follow-up question in the tokenization part itself. What types of sensitive information are best suited for tokenization? So, if you talk about tokenization as one aspect of PET, we have different data classifications, different kind of a sensitive data. So, my follow-up question would be for you, would be what kind of a sensitive information that are best suited for tokenization?
Okay, so it's in a very simple way we can understand that any sensitive data that can identify a person or it has a high business value, it is definitely, it can be a good candidate for tokenization. So the common example, if we see, it could be your credit card number or your Aadhaar number, PAN number, passport number, mobile numbers, email IDs, customer IDs, healthcare records. So any of these information or all of these information are sensitive information, and these can be tokenized. So the idea here is very simple. If an application, it does not need the actual data, why to expose the data to that application? So if we can work with a token instead, so while the real data remains securely stored in a token vault. So from this particular scenario, the takeaway can be that the less sensitive data, the less the sensitive data you expose, the lower the risk. And that is why tokenization adds the most value to any stack.
Correct. And we hear a lot about vault-based tokenization, vault-less tokenization as well. And this is where I want to bring in Harsh. Harsh, can you also give us a clear difference between vault-based tokenization and vault-less tokenization? And if any organization going ahead needs to adopt for vault-based tokenization and vault-less tokenization, what are the things that that organization should take care of? And what could be the exact difference between vault-based and vault-less tokenization? Harsh, if we can answer that.
Yeah, sure. So, but by the very sense of it, by the term, as you can say, vault-based and vault-less means the absence or presence of a token vault. So traditionally, vault-based tokenization was something which was the go-to solution, but nowadays with the ever-evolving, say, ecosystem of technology with AI solutions coming into the picture and modern microservices architectures being built, and even the transaction rates and throughput need the requirements going up very fast. That is where I would say vault-less tokenization is something which doesn't rely every time on fetching the data from the vault. Makes a lot of sense. So vaultless is a slightly newer, more modern approach towards tokenization, and not just about which one came first and which is the more latest one, but also if you see, it's about whether or not there even is a requirement to get the plain text data back or not. So take, for example, a situation where you're running certain analytics. Okay, so there is an organization, it has received a lot of customer data and it wants to perform some analytics on this data to understand the user patterns or to understand or do some kind of targeted marketing campaigns based on anything. In such scenarios wherein the only information that the organization wants is largely based on correlation. So for example, user A is doing so many transactions in a week, or user A has repeatedly purchased this one item for so many times in the last 1 month. You don't really need to know who user A is, right? You only need to know that user A has done a specific activity for so many times. So when you don't need the sensitive data, that user A can have lots of sensitive information about that person that is the system is capturing. It can be the phone number, it can be the email address, it can be credit card number, whatever. You can use vaultless tokenization because you don't really need to detokenize that value. Vaultless tokenization nowadays does offer detokenization options as well, wherein you have to use certain deterministic techniques through which you can perform a certain specific algorithms which will allow you to get back the sensitive data. Another benefit that vaultless tokenization offers is that of being format preserving in nature. So if you want to, again, as I said previously in the examples of encryption, wherein you don't want to break database schemas, if you want your applications to process certain data without having to make any changes, if you want the format to be preserved, that is again where vaultless tokenization is inherently going to preserve the data, the format of the data. Vault-based tokenization largely is when you want to retrieve sensitive data, and also when this sensitive data that you're storing has got a very long validity period or a very long lifespan. So if you say in India, we have Aadhaar number, we have PAN number, your driving license or passport also is issued for 10, 12 years, like that. And again, in such situations also, when say tomorrow going forward, you want to update any details, you don't have to make any say changes, or the applications don't have to really know that the underlying sensitive data has changed. So even in our solution that we have, that is PI Data Vault, you can rotate the encrypted data. So when we talk about rotation specifically in the case of say vault-based tokenization, we rotate the sensitive data which is already stored in the vault. The reference token that has been mapped against this sensitive data has already been consumed by the applications that is not getting rotated. So that is again one benefit. With regards to the implementation complexity or which approach should you choose, again, as I said, I think legacy applications are much more easier to integrate for vault-based tokenization approaches. The vault acts as a central point of reference for the applications to fetch sensitive data and perform the operations, whether or not the data is tokenized or it has to be detokenized. Another thing is, it depends on how much the scale of the data is. If you have, say, 50 microservices, or if you have 100 microservices or 100 applications, which are going to, say, send the sensitive data, then again, in that case, if you have a vault-based approach and if you want the plain text data back, having so many or if you have, say, even multiple locations in which all these applications are spread. So if you have multiple environments, you need to provision the vault accordingly. If you are a security services provider, which again, you need to provision independent vaults for each and every customer or each and every tenant, then it is only supposed to be done in a very careful manner, wherein yes, you understand that there is a specific requirement for vault-based tokenization, and that is then the solution that you want to offer. Otherwise, I would say that for high throughput, high volume transactions where detokenization is not important or not necessary, you can proceed with the vaultless approach as well. So yeah, that's how I would put it.
Yeah, that's great. I mean, thank you for sharing those insights between vault-based and vaultless tokenization. And what I personally also feel that, the customers, the potential customers that come down to this Optic organization, we give them a proper baseline on what kind of a tokenization would work for their environment, right? We do that initial analysis, and then we provide the solutions with terms of POC and demo. So that is some prerequisites that we do in terms of any client clients that come along with us for tokenization projects, right?
Yeah, absolutely.
That's great. So I also wanted to pick up the progressive part of the tokenization discussions that we had, and as of now, many organizations are now adopting AI and analytics, and then that would be my next question. So can tokenized data still be useful for businesses operations, or does tokenization limit those usability? Harsh?
So it again depends on which part of this AI ecosystem are you trying to implement the tokenization solution, So a lot of it is the initial part, or rather a continuous process of enhancing AI models or AI LLMs is performing the model training. So when you train a specific AI model on the customer data set or any kind of data set which may contain sensitive values, again, if you are trying to perform a training kind of activity where again the sole purpose is wholly the correlation of the data. So if you want to identify the usage pattern, or if you want to build certain inference rules based on the underlying data, there again, you don't need to understand the actual context or the actual, say, name of the person or the age or whatever, gender, these kind of sensitive informations. So yes, a large part of AI-based applications or AI activities can be performed on tokenized datasets. There is no limitation because, as I said, worthless tokenization is a format preserving activity. So you can say you can safely perform the activities which you are going to perform on the actual sensitive plain text data on a tokenized data set. The AI model doesn't really recognize or doesn't understand by itself that the data has been tokenized beforehand in the case of worthless tokenization. So this is where I would say that yes, the scope for this kind of solution is huge. If you want to, again, say, perform any of the activities which involve the utilization of the actual sensitive data, for example, say KYC matching against the government records, or if you want to say if your AI agent wants to send the personalized emails, then in this case, the application may have to detokenize the data, or it has to avoid tokenizing that field altogether. So it doesn't really necessarily reduce the usefulness of AI, because most models, they learn from the relationships and frequencies and behavioral patterns. So by replacing the sensitive identifiers with a consistent tokenization pattern, the organizations can perform certain activities such as training or analytics and fraud detection while significantly reducing the exposure of the personal data. And only in certain use cases which require the original identity, the detokenization is required.
Yeah. Thank you, Harsh, for sharing those insights as well for tokenization and encryption. So now we come to the third part of the privacy enhancing technologies, which is data masking. And for the data masking, I would like to come to Gaurav. So Gaurav, unlike encryption and tokenization, masking doesn't always aim to recover the original data. What exactly is data masking, and where does it fit into the privacy strategy? If you can explain. Gaurav, you are on mute. Yeah.
I'm sorry.
Yeah, that's it. Yeah.
Can you hear me now? Okay.
Yes.
Okay, so to answer your question, Sharda, actually data masking is all about hiding sensitive information from the people who actually don't need to see the real data. So if we take up an example that, when a customer support executives, he looks at your credit card details. So, they might not see your entire credit card number, but they can only see the last 4 digits of the card. So they can do that job pretty well even if they do not see the entire number. So they don't have the access to the complete information, and that is what exactly is data masking. Unlike encryption, if we see or tokenization, the goal here isn't to recover the original data every time. The goal is simple, to show only what is necessary and hide the rest of the data. So, it's commonly used in customer support or testing environments, analytics, the reports, where people need not to work with the data, but they don't need to see. They need to work with the data, but they don't need to see the actual sensitive values. So this is basically what is data masking and how it is used.
Yeah.
Chada,
So,
okay, please.
yes. So I would like to bring in Harsh quickly for the format and realism of data. So Harsh, can masking preserve the format and realism of data while still protecting the sensitive information? And how is it important?
Yeah,
Harsh,
so see, technically speaking, I would say tokenization and masking, or rather each of these three terms, they are often used interchangeably in the industry. Especially tokenization and masking is something which can be overlapped. So with regards to what kind of masking are you performing, it really matters. So modern data masking solutions, they do preserve the format or length and the realism of the data while they actually replace the original sensitive values. And this is where most of your scenarios with respect to, say, performing any development or testing kind of activities for organizations, they rely on the masking techniques. So the underlying principle of tokenization or masking are terminologies or concepts such as pseudonymization or anonymization. So what happens in anonymization is it is where you are actually redacting certain values, and it is like a one-time activity that you're performing on the masking, so you don't get the original plain text data back. So in the say pseudonymization, that is the dynamic masking, that relies mostly on focusing on hiding the data from unauthorized users at runtime. So these can also be format preserving techniques. So it depends on which kind of approach you're mostly relying on. So if you're utilizing any of the format preserving mechanisms, then yes, even for tokenization as well as for masking, the data formats are preserved and the realism of the data set is also, say, maintained.
Harsh, just wanted to know about the limitation part in the tokenization. So in what situations should organization avoid relying solely on data masking?
Okay, so this is where the masking techniques, as I said, whether it is static masking or dynamic masking, nowhere are we trying to um, do any kind of, say, operation where the actual sensitive data is completely getting altered or say removed from the system or getting protected in a single location. So if you talk about static masking, you're from the sensitive data, you're creating a sanitized data set or a desensitized data set. The original plain text sensitive data, you're not really altering that. So that is still somewhere it is present in the system. So it doesn't say protect this data. And it is again not a suitable technique when the original data itself needs to be stored securely. So if there is a situation where an attacker attacks on the production data set, masking doesn't offer the protection because the original data is what is getting stored. Masking is
I think we lost
applied
you, Harsh, again.
to the data in a different environment, or say the data at the time of retrieval that is getting dynamically masked. So this is where you to say focus
Hello.
on the different aspects of your entire infrastructure, focus on the exact use case. That is exactly what privacy enhanced technologies are all about, wherein to protect the data
Can you
at
relog in,
rest, mainly
Harsh,
you have a lot of
if I'm
encryption
audible to you?
techniques which come into the picture to protect the data in transit, say, or in use. That is where you can rely on certain, say, tokenization or masking techniques. Masking most likely is something which is utilized when you're trying to present the data on the screen to any specific user. So if in a bank, there are two sets of employees or two sets of users, and for any, say, processing activities of, say, processing the loan or any claim, that particular employee of the organization does not need to view the data complete data in plain text manner to perform the further processing, that is where masking comes into the picture. So there aren't many limitations as such with the original, so the concept of masking. It is just that relying on it solely is a dangerous proposition.
Okay. So I think there have been some technical glitches as well while you have answered that. But in a summary, we get the limitations, what kind of a limitations that could be for data masking, the way you have explained, Harsh. Now we have given a lot of insights on encryption, data masking, and tokenization. I would like to, from an organization point of view, if it's like encryption versus tokenization versus masking. So which privacy enhancing technologies one should use? I mean, so for this question, I would like to bring in Gaurav. So we have seen day in, day out that organizations ask which is better, is it encryption, tokenization, or masking? And we have already, and we'll tell them that this is going to be a wrong questions to ask. So Gaurav, if you can also, justify this statement in terms of when the organizations come to us and say that will it be encryption, will it be tokenization, or will it be masking? Yeah,
Right. Yeah, thank you, Sharda. I would actually say, the question itself is wrong, that which one is, correct, because it's not about which one is better or which one is right. It's about, which one is right for your use case. So, talking about encryption or tokenization or masking, they all solve different problems. And if you want to protect your data, like, let's understand this way. You want to protect your data from unauthorized access. So encryption is the best choice or the right choice. So if you want to reduce the exposure of your sensitive data across applications, then tokenization is a great option. And if user only needs to view part of the data, so masking is the best approach. So in fact, what happens? Most organizations don't choose one over the other. They use them together as a part of a layered privacy strategy. So what we can say that which tech we should not know, people should not ask which technology is better. Rather, they should ask what problem am I solving, and that is how you have to choose the right kind of a privacy solution.
Yeah, that's correct. Yeah. So, I mean, that's a great way to put it as well, Gaurav. For any organization who are actually want to pick and choose. So, I mean, for encryption versus data masking versus tokenization. So,
just one point to add on to Gaurav's answer.
Yeah.
The say end goal of trying to implement any of these solutions, be it encryption, tokenization, or masking, needs to be that your business processes or your applications are not affected to a large extent. Business continuity needs to be maintained. That is something which organizations should keep at the top of their priority list when they're trying to assess the various solutions, apart from identifying their use case or their overall environment. If it is, again, something which, or an environment or enterprise ecosystem which has got a lot of legacy applications, then there needs to be a thorough evaluation done of whether or not the modern or emerging technologies will actually even integrate with these kind of solutions, and how will the performance be affected. So all of these metrics need to be covered. So it's true that neither one of the solution needs to, or neither one of the solutions is not going to suffice the complete end-to-end requirement, but it also needs to be then a question about what is the right combination of solutions that we're using, whether we are really needing all of these solutions in all of these places, or can we utilize only one or two of these solutions completely end-to-end and deploy them in a way that you're managing the entire data protection piece of your organization. So it's equally important to assess that part as well.
Yeah. That's an important point, actually. The combination of all three, not just pick one. So if you are picking one, we are just doing no good to your business as well in terms of your security infrastructure is concerned. Yeah,
Yes.
that was a great discussion, Gaurav and Harsh. Thank you so much for joining this webinar, CryptoBind Digital Insights, and throwing a lot of insights on the privacy enhancing technologies. I think with the audience for the greater good, there will be a lot of questions in terms of the doubts and everything, what this technology is all about. So I think those would be answered, and we'll be happy to address those questions apart from this webinar as well. You guys can, we are pretty much available on LinkedIn, we are pretty much available on the website and everything. So drop in your questions if you have any other doubts in how can we go ahead and accommodate these technologies into our organizations, how can we move ahead with questions, or you can just say hi in terms of the cybersecurity discussions as well. So with that's a wrap, I think, from our end. Again, thank you so much, Gaurav and Harsh, for sharing your insights on PETs. And we'll hopefully see you in the next webinar.
Thank you, Shada, and thank you everyone for joining the session.
Yeah.
Thank you.